In this video, I will be trying to explain these problems again and give you the key to my study guide. I will also be giving you an 11-word message that I want you to prove to me that you watched this whole video. So here we go. First problem. It says in the equations f of x equals g of x plus 5, where f of x equals 4x minus 3, which represents the vertical shift from g of x to the new line f of x. Remember, this g of x is the original equation, always in this form. This is where the original equation is going to go. This is what I do once I plug that original equation in there. So once I plug in g of x, I'm then going to take that and shift it up the y-axis 5 points. This is kind of misleading. This is the equation after the transformation, so this has none of the vertical shift numbers in it. So what I need to do again is look at this, see that this is where the original function goes. It's going to move up 5 boxes. That is the vertical shift number. For this problem right here, again, same kind of idea. This tells me what the original equation is and what the new one after. I'm done. So this right here shows me where I plug in the original equation, the original function. This tells me what I do to it. This gives me what, after I've done that to the original equation, this gives me the transformed equation. So this, g of x, is the original equation, I know, because that spot right there tells me this is the original equation. So I'm going to graph it. So I go to positive 2. This slope of negative 1 over 2 means every time I go over a box, I go down a box. So over 2, down 1, over 2, down 1. Be able to stair step both directions. That line right there is g of x. To get from that original line, g of x, up to this new line here, f of x, I'm moving up that y-axis 2 boxes. That is my vertical shift. That is the answer. I take that, move it up 2 boxes, and that gives me negative 1/2 x plus 4. That is the new function. But again, that vertical shift number of 2 is that number right there. All right, next problem. Again, look at this to know what you're doing. This one has f of x as the original function I'm plugging in, and then I'm adding k to it. Well, I need to find what k is. So again, f of x, the original function. So looking at my graph, this is the original function. To get to the new line, g of x, I'm moving down the y-axis 2 boxes. So that is my vertical shift. Sorry about these duplicate numbers right there. But again, look at this to know what you're doing. This problem right here, g of x, this first one is no good because positive 4 is up here and the g of x's y-intercept is down at negative 1, so that's bad. F of x, looking at that, f of x is up here, its y-intercept is 4. That's showing a y-intercept of negative 1, so that is bad. This situation says start at f of x, the original line, and move it up 5 boxes. So if I start at f of x, the original line, and I'm moving it up 5 boxes to get this new g of x line, that would be taking this f of x line and moving up 5 boxes. But that's not the case. That is not the answer. Next one. F of x equals g of x plus 5. Again, this is the original function. This tells me what I'm going to do, or it tells me where I'm going to plug it in, and 5 tells me what I'm going to do to it. So I take that line, g of x, I'm going to move it up 5 boxes up the y-axis to get my new line f of x. So that one is a true statement. All right, the first word coming. The first word is the. T-H-E, the. That's the first word, T-H-E. All right, next problem. Backside. This one right here says mean, and I'm not quite sure if they're meaning median, but we're just going to say medians for this problem. So the mean score per game, I don't really know if I could find that out because I don't have all the original scores. I don't know how many games. I know they played. Oh, I don't know how many games they played. So that one does not apply. No conclusion can be made regarding we'll think this is medians. And I'm going to cross that one off. The median score per game is lower for Central than South High School. This is the median, that middle box. If I look at the median for South High School, it is 30 right on that line. 30 is the median. If I look at the median of Central, it looks just past 30, maybe about 32. So with South High School at a median of 30, Central at 32, the median score per game is lower for Central than it is for high school. And again, let me look at that. That one is not true. All right, last one is good. The median score per game is higher, yep, for Central than high school. This has a median of 32, where South High School has a median of only 30. All right, next question. Data skewed to the right. Yes, that is the case. Data skewed to the right for a box and whisker plot shows an extra long tail on this right side. Shows that most of the data, if you look at that, is off to this left side. So for this, a box and whisker plot with a longer tail on the right, or if this median is more to the left side of this box here, showing most of the data is to the left, that is skewed to the right. The interquartile range is the distance from here to the edge of the box. That is the interquartile range. The interquartile range for A here is short. For B, it's longer. So that is not a true statement. The range is all the way across. So the range of B is larger than all the way across for A. So this one would not be the case. And then left skewed would be a box and whisker plot that would have a longer tail to the left, shorter tail to the right, or the median would be to the right side, so that is left skewed. If it was a box and whisker plot, right skewed, longer tail to the right, and then the median, the middle number of the whole set, would be more towards the left of this interquartile range or that box. Left skewed, more to the right. Next word coming, the word is blue. B-L-U-E, blue. All right, next problem. For this, it says, based on this data, which is true? So looking at this, Class B has a greater median than Class A. Looking at my medians, or this number right here in the middle of the box. For Class A, looks like it's right about maybe 26. Class B looks like it's maybe about 16. Class C looks like it has a median of about 17. Those are my medians. My interquartile range is from here to here. So Class B has the biggest interquartile range. My overall range, all the way down, Class C has the largest overall range. So looking at this, Class B has a greater median than Class A. That is not true. Class B has a median of 16. Class A has a median of 26. Class A has a greater interquartile range, and then Class A, that would not be true. This is shorter than B. B is longer, so that would not be true. Next, Class C has a greater median than Class B. That would be true. Class C has a median of 17. Class A has a median, Class C, back again. Class C has a median of 17, where Class B has a median of 16, so that is true. Class B has a greater range, so yes, this is, oh, nope, that's not true. C has a longer range than B, so that one is not true. Next, these correlation coefficients used to answer these problems here. So for this one, Serena's line fits her line data better than Archie's. Serena has a correlation coefficient of 0.92. Archie has a correlation of 0.097. Even though that's negative, that is better. So that is not true. Serena's line has a lower correlation, which means her line will not fit as well as Archie's. Serena's line fits her data better than Jana's line. Serena 0.92, Jana 0.95. Again, that is not true. Jana has a larger correlation coefficient. Her line will fit better than Serena's. C. Archie's line 0.97 negative, Jana 0.95. Archie, even though this is negative, this has a number larger, closer to 1 or negative 1. This one's close to 1, but not quite as close on the other end of the scale. So this is true. Again, the scale goes from negative 1 to positive 1. We're close to 0, lower correlation. Your line will not fit the data as well. Closer to these sides, the line fits the data perfectly. Jana's line fits her data better than Nate's. Jana 0.95, Nate 0.99, almost perfect. But nope, that is not true according to that statement right there. Jana's is lower. All right, next. Of these numbers up here, which has the better correlation or the higher confidence, which has the higher correlation number? Again, the scale goes from negative 1 to 0 to positive 1. Anything close to either side of the scale, the closer to, is going to be the higher correlation coefficient. Next word coming, the third word, is car. Car. All right, number 10. For this correlation coefficient going up, positive correlation. If I look at this, which best fits this? Since it is positive, I know this is not true. Negative would have the points going downwards like that. 0 would have the points so scattered I could not even draw a line through them. The fourth word is coming. The fourth word is bad. B-A-D. So I've had 4 words so far. The 4 words are the, blue, car. The fourth word is bad. So the, blue, car, bad. Those 4 words. Listen for the rest. Back to this problem, number 10. 0.95 is really, really high, almost in a perfect line in the positive direction. 0.83, a little bit lower, so I would go more with 0.83 since those points are a little bit more spread. Okay, problem number 11. What I'm going to do for this, I'm going to draw a line of best fit through here and use it to answer some of my questions. So I take that data. I'm going to say maybe about here. I got about 1, 2, 3, 4 on the bottom, about 4 on the top. So maybe more about here. There we go. How about that? All right, using that line, now answer some of these questions. It says the model is negative 1.6 minus 4.6. So again, this is the slope, negative 1.6, which means every time I go over 1 to the right, my height, 1 inch, I go up. I'm sorry. Model by, we'll say this is plus right here. Sorry about that, you guys. So that means every time I go over 1 inch, I go up in height 1.6, or I'm sorry, every time I go up an inch in height, I go up 1.6 pounds. So 1 inch, 1.6 pounds. 2 inches, twice that. So again, I'm going to use 1.6 as my rate of change. That's the number I want you to focus on the most. Don't worry about that so much. So looking at this, every month the dog grows an average of 6 or 1.6 pounds heavier every month. And again, that not looking good. This one, when dogs were born, their average weight was 1.6 pounds. Again, that really doesn't fit the data. For D, I'm going to cross this one off here. C, for this one to work, it means every time an inch is added to the height, 1.6 pounds is added to its weight. So every time I go over an inch, I go up 1.6 pounds. That is the slope 1.6 over 1. Every time I go over 1 inch, I go up 1.6 pounds. That's what that graph is showing. So that would be C for that one. All right. Probably what I'll have you do for work is maybe show me this. Okay, the next word is coming. The fifth word is went. W-E-N-T, went. So spelled just like that. All right, number 12. And again, to review, just to help you guys out, the words are the blue car bad, and then went. The blue car bad went. Those are the 5 words so far. First, second, third, fourth, fifth. All right, next problem here. I'm going to erase that for the people not paying attention. All right, for this next problem here, for this one, time spent studying hours. Looks like for every hour spent, my test score goes up by 10. It also shows me that at 0 hours, the y-intercept here has 10 as my score, which means at 0 on the y-intercept, the score is 10. That is the answer, but let me show you the ones. This one says the student receives 1 point for every additional hour spent. 10 hours spent, and that would be way over here. No, that would be not true. A student who does not study for the test receives a test score of about 10 points. And again, the graph showing that at 0 time, the score is 10. At 1 hour, going up to my observed value, looks like the score is 15. At 1 hour, going up to my predicted value, the score is 20. Looks like I have 2 observed values here. The second observed value would be 25. At 2 hours, the predicted value, 30. At 2 hours, the observed value is 40. So again, talking residuals there. But again, for this, at 0, 10 was the score. This one says a student receives 20 points for each additional hour. And again, that would not be true because looking at the slope, every time I go over 1 hour, my score goes up by 10. So that would be a slope of 10x. But again, that is not true. That says 20. This one, a student who studies 10 hours for the test, way over here, it's going to have a way higher score than a 0. So that one's not true. All right, next problem. For this two-way table, first, it is filled out for you. This X means this is the spot on the table. That's the number they're wanting you to do. For number 13, relative column frequency means I'm comparing to my column totals. These are my columns. So relative frequency for my column is 30 divided by 50, 20 divided by 50, 30 divided by 80, 60 divided by 130, 70 divided by 130. All the numbers divided by the column totals. So for this one, taking 30, which is X, and dividing by the total of that column, that's 50. So 30 on my calculator first, I type in 30. I hit the division button second, and then I type in 50. The calculator should give you something like that. 30 first, divided by second, 50, equals, gives me 0.6, which rounded twice to the right, or moved twice to the right, gives me 60%. All right, 14. This says for y is this 50 number right here. That's the spot in the table. This says row relative frequency, meaning you're comparing everything to the row totals, these numbers. So 50 divided by 130, 20 divided by 70. If you do 70 divided by 70, that's why you get 100% when you're doing row relative frequency. But this says y, which is 50, divided by the total of its row, which is 70. 50 divided by 70 gives me 0.714. Rounded to this second place, this number not big enough to round it up, so 0.71. Move twice to the right, gives me 71%. All right, next problem. Whole table. The whole table you compare to only this number right here. All the numbers to the whole table's total. So z right here is 50. 50 divided by the whole total 130 gives me 50 divided by 130, which is 0.384. This is not enough to make that round up, so 0.38. Decimal move twice to the right. Decimal new places right there. Gives me 38%. So 15 is D, 14 is D, 13 is D. All right, reading a graph. 2010, go to 2010. If it's the observed value, you go to the point and look where that point lines up on the y-axis and give me that number. If it's the predicted value, you go up to the line and look and see what that value is here on the y-axis. So 2010, observed. So I'm going up to the point. Looking over, looks like just below 1 on the y-axis. That's why I choose D. 2008, predicted value for 2008 means I'm not going up to the point, I'm going up to the line and looking where it crosses the y-axis right here, 2.5, or a little bit lower, 2.4. Predicted value means again I'm going up to the line. So 2011, going up to that line, looks like right on that dotted line exactly, that would be 1. All right, the sixth word is coming. The sixth word is Joe. That is word number 6, Joe, J-O-E. All right, next problem. All right, this problem has you figure out the percent of total responses from the females who get their information from social media. What percent of total responses? So for that one, I take my females who get their information from social media, females, which is 90. I'm finding the percent compared to the total number of responses. That means I'm comparing to this number right here. What percent of the total responses? So that's going to be 90 divided by 90, or I'm sorry, 900. 90 divided by 900 gives me 0.1, which moved twice to the right, is 10%. So that would be D. All right, this one, a little bit harder. What percent of the males, so this is saying what percent of just the males, of just the total males, not the total responses, which are all the responses all together. This is asking for just the percent of the males. So if I look at newspapers and males, I have 150. Do not divide 150 by the total number 900. That answer will probably be waiting there for you. Don't do that. This is just for the total of males. So if I look at the total of just males, that is 300. So this gives me 150 divided by 300, which is 0.5, which is 50%. So for example, if I wanted percent of just females that read newspapers, that would be 90 divided by 600. If I wanted number of females that read newspapers compared to total responses, then I would divide it by 900. All right, next problem. 21. This says, of this triangle, look at it. These angles are equal. These two sides are equal. These angles are equal. They can show you one little line here means these are equal. Vertical angles always equal. These double marks mean these corresponding angles are equal. These little marks right here show that these two sides are equal. All right, my seventh word is coming. My seventh word is over. So for this problem, saying XY, this length, is equal to length AZ. That is not true. These are not equal. They don't have lines there. For B, this says angle ZBA. So angle ZBA, this angle right here, is equal to angle YXZ. So angle ZBA, in that order, ZBA, that means the angles right between them, ZBA, that's this angle right here. Angle YXZ is this one. These are not equal. The next one, XZ, is this length equal to YZ? That is not true. Those are not equal. They don't have lines there to show you they're equal like these two. XZ, so this part right here is equal to this side right here, and yes, that is true. This length, as you can see, corresponds to this. These are congruent triangles. This has an angle, and a side. Angle, side means these are congruent. So that means this length between these two angles is equal to this length. That is true. All right, next problem. Same kind of idea. It's saying these triangles are congruent. Why do these parts show that these triangles are congruent? It says line XY is equal to line AB. I'm going to put a line there. That means those two sides are equal. Next, it says angle XYZ. That is XYZ. That's this angle right here. XYZ is equal to angle ABC. So I'm going to put a little line right there to show those two angles are equal. And then it says YZ, this length, is equal to length BC. So I'm going to put two lines there. Looking at these, it goes in kind of counter or clockwise pattern. Let's go right here. Let's start right here. A side, an angle, and a side. An angle sandwiched between two sides. That shows congruency. Angle sandwiched between two sides. Side, angle, side. Side, angle, side. That is what proves that those two triangles are congruent. So look for that combination, side, angle, side, on this problem. All right, 23. For this one, I'm going to get a little bit of patty paper. For this problem, I am moving from here to here. This is my pre-image. This is my image. I could tell by these little marks. So my pre-image to my image. So again, pre-image and my image. And I could tell by those marks. No marks, that was before. This was after the transformation. So looking at this, it says reflect about the y-axis. So that means I'm going to take this and reflect it over here, which would look like this, and then rotate it 180 degree clockwise. So let's see if I took that. This is the reflection across the y-axis. If I rotate that 180 degree counterclockwise, that around the origin, that means from here, with my little line of reference, I'm moving 180 degrees counterclockwise. This is clockwise, like a clock, counterclockwise. So that would be taking this triangle right here and moving 180 degrees counterclockwise. And you can see, not even close. Nope. Reflect across the x-axis and rotate 180 degrees counterclockwise again. So this time I'm going to reflect it across the x-axis, right there, and rotate it 180 degrees counterclockwise. So here we go. There's 90 degrees. Nope, not 90. Oh no, that's no good. All right, next one. Reflect across the y-axis and rotate 90 degrees clockwise. So take that triangle, reflect across the y-axis, straight across, equal size. Looks like I need to move that over to be a true reflection. There we go. So equal distance across that line of reflection. And now I'm going to rotate that 90 degrees clockwise. Looks like that might be the one. I'm going to double check. Yes, it does look like that one is the correct answer. You might need to change that on your key. So let me double check. So reflect across the y-axis means I'm reflecting over here and then rotating 90 degrees clockwise. This is a clock in this direction. So if I reflect it first straight across the y-axis, this up and down line, there's my triangle reflected, and then I'm going to move it 90 degrees clockwise like a clock. So that's going to go move my arrow from here 90 degrees would be right there, and you can see it ends up right there. So that is the correct answer. D is incorrect, because if I look at that, if I reflect that across the x-axis to here, and then I rotate that 90 degrees clockwise again this direction, it ends up here. So that one is not true. You need to fix that. Okay, the next word is coming. The next word is high. H-I. That is my 8th word. So I've had 8 words so far. The words are the blue car bad went Joe. The 7th word is over, and the 8th word is high. H-I. So the blue car bad went Joe over. High is the 8th word. Over is the 7th word. Joe is the 6th word. Went is the 5th word. Alright, here we go. Keep on going. For this one, I need to find the perimeter, which is the length all the way around. I have a flat section here, so I'm not going to use the distance formula. I'm just going to count. 1, 2, 3, 4, 5, 6, 7 boxes long right there. For these two sections, I will use the distance formula. So A is the point -3, -1. B is the point 0 for x, 2. C is the point 1, 2, 3, 4, -1. So I need to find the length of AB. So that would be subtracting my x's, subtracting my y's, using the distance formula. So that gives me -3 minus 0 squared plus -1 minus 2 squared. Gives me the square root of -3 squared plus another -3 squared. Square root of 9 plus 9 is the square root of 18. That is the length of AB right there. BC, I'm going to subtract my x's, subtract my y's. The length of BC is 0 minus 4 squared plus 2 subtracting a -1. 2 minus -1 turns into 2 plus 1 squared. Gives me -4 squared plus 3 squared. 16 plus 9, the root of 25, which is the whole number 5. Adding those up, I get 5 plus 7 plus root 18. So on my calculator, I'm probably going to type in root 18 first. So hit this second button and then the x squared button, you'll activate that little square root part. Type in 18, close that parenthesis, plus 5 plus 7 gives me 16.24. Hopefully you can see that, 16.242. So 16.242. This number rounded to here, that's not enough. Leaves 16.24. That would be D. Alright, this one. This line, the line K, they give you the slope. That is -3/1. You could have found that also by going over 2 and down 6. -6 is my rise, even though that's going down. 2 is my run, even though that's on top. This is my rise, negative. This is my run. That's a slope of -3 or -3/1. Perpendicular. This line L looks like and is perpendicular. So a perpendicular line has negative reciprocal, which means I take this and I not only flip-flop it where that 1 goes at the top and -3 goes at the bottom, but I do the opposite. So this is negative, the opposite is positive. Negative flip-flop. So any of these lines down here with this same slope will be the answer. This one has a slope of 3, -3. -1/3, slope of 1/3. That is good. That is the one. Next problem. Alright, for this, I want you to show me how these numbers change, or what we're trying to do again is trying to make it match up to this. So my lowest one right here is 101. My first median, my first quartile is 106. My median or middle quartile or median of the whole set of numbers is 112. My upper median is 116. And my upper number, my maximum, 119. Minimum 101. Maximum 119. First quartile 106. Second quartile 112. Third quartile 116. So again, I'm going to list these numbers out and see how this number changes it. So 101, 106, 110, 111, 113, 115, 116, 118, 119. I'm going to write that out for all of my choices. This is the work I want to see. So write them out. Whoops, that would be 101 right there. Sorry about that. Might be better to do these one at a time. Alright, so my first one here. 112. What I'm doing, I'm adding 112 to this. So 112 would be right here. That's where 112 would be. Finding my median, starting from the outside. I can see that 112 and 113 are here in the middle. I need to find the number between them. So to find that, I take 112 plus 113 and divide that by 2. That gives me 225 divided by 2 is 112.5. So that shows me my median, if I plug in 112, is 112.5. But that does not match my box and whisker plot, so that is a bad choice. If I plug in 111 right here. For this one, counting from the outside in, I could see these two numbers make up my median. So if I add 111 and 113 and I divide by 2, gives me 224 divided by 2. That is 112. So that median of 112 still matches my data set up there, or my box and whisker. I'm still looking good. That is 112 right there. So now let's look at the rest. Now, again, unfortunately, I might have taught you the wrong way, but to reteach it again, this is my middle number of the whole data set, 112. I'm now going to find the middle number of all 5 of these, and then find the middle number of all these 5 up here for the top. So even though I use these 2 to add up to find that middle number, that is just the number between all of these. I still use all 5 of these to find that bottom median. So that bottom median would be 110. That top median would be 116. This looks good. 101 minimum. Oh, but 110 does not match this 106. That makes it bad. This is still good. This is still good. My maximum is still good. But because of that, that does not match. That would have a median down here. This would be shifted up to 110. All right, for C, if I add 106, I still have, coming in from the middle, these 2 numbers to give me my median. That still gives me a median right of 112, adding these 2 up and dividing by 2. So now if I look at the median of this whole bottom half of numbers, that would be 106 minimum. Median of this top half of numbers up here, 116 maximum. That looks good. Perfect. Perfect. Yep, perfect. Perfect. Good. All right, if I plug in 105, 105 would go right here in order. Again, still would have a median between these 2 of 112. The median of this bottom half, 106, looking good. Minimum 101. Median of this top half, 116, still looking good. 119, looking good. So both those are still good. They still make your data match this box and whisker plot. For this one, 101, if I add 101, again, I still have 112 here, looking good for my median of the whole set. 106, good. 101, good. Median of the bottom half, minimum. Median of this top half of numbers, still looking good. 119, looking good. And then again, remember, interquartile range from here to here. The whole data set's range all the way. If I plug in F 100, as soon as I plug in 100, I know it's bad because that's showing me a minimum of 100. This has a minimum of 101, so right away I know that's bad. All right, next for this one right here. Remember this range, this is 60 through 64. So this section right here starts from 60 and goes to 64. This next set of 5 right here goes from 65 to 69. This section next to it goes from 70 to 74. This goes from 75 to 79. This section right here goes from 80 to 84. This section goes from 85 to 89. Next section from 90 to 94. Last section from 95 to 100. So looking at this data, finding the one that matches. Looking at A, I have 65, 65, 69. Those are numbers in this range. I got 3 of them, so my histogram correctly goes up to 3 to show me there's 3 of those in that range. If I go to 71 and 74, that's in this range right here, but my histogram shows me there's 3 of them. I only have 2 of them. So right there, that discrepancy shows that this data does not match this histogram. That is incorrect. If I look at my next one, sorry about that. Hopefully that wasn't on there too long. Hopefully. But again, looking at this, again, 65, 65, 69, 3 numbers in this range. Correctly goes up to 3. But when I get up to 71 through 74, this next, it goes up to 3 also. I only have 2 here, so that does not match. Next one, 60. I have 1 number in this range, but this histogram shows nothing. Wrong. Next one, C. 65 to 66, 67 in this range, 3 of them. Perfect. 71, 73, 74, 3 numbers in this range. Perfect. 75, 79, 2 numbers in this range. Perfect. 82, that looks like there's only 1 number in that range, 80 to 84. Yep. 87, looks like from 85, yep, 1 number in that range. 91 to 94, looks like I have 3 of those from 91 to 94 right here. I'm sorry, 90 to 94. 3 of those. And my last 2, 95 to 97 right here. From 95 to 97, or sorry, 95 to 99. That goes up to 2 of those. So 95 to 99 right there. 95, 99. So that one is good. This one again, because I have a 60 and there's nothing showing in that range, that one is bad. Alright, the next word coming, the next word is the. The 9th word is the word the. T-H-E. Alright, next side. Alright, for this, what I'm going to have you do is focus on the rate of change numbers for this. So for this one, it says Mia uses this equation, so focusing on this rate of change, -12, which shows me after every week it goes down 12. This one, I need to find the rate of change for Carmen. So to find the rate of change for Carmen, I look at this table here. These numbers represent N, or really the letter X. These are the M of N numbers, or really the Y numbers. So I need to find this rate of change, which is slope. Rate of change is change in Y over the change in X. So I need to find the change in Y here. So 240 minus 180 looks like it's going down by 60. That is my rate of change. And I'm going to make that negative. The change in X from here to here is going down by 4. So I'm going to use that and leave that positive here. So if I divide that, that gives me a rate of change of -15. And so I'm going to use Carmen's rate of change as -15. Mia's rate of change is -12. Alright, this says Carmen will save $300 in 12 weeks. If I take 300 for N and plug that into Carmen's equation, which is -15N, that gives me -15 times 12. Let's see how much she saved right there. That gives me 12 times 15. That is 180. So that is not true. Carmen will save more money each week than Mia. Carmen's number is 15. That is more than Mia's number. That is true. Carmen's number will go up. Her numbers will go change faster than Mia's number, so she will save money faster. All right, Carmen and Mia will save the same amount. That is not true because these rates are not the same. They're not saving the same amount of money or the same rate. This has Carmen saving more money, Mia saving less. And negative meaning their amount of money they're needing left to save is going down faster. All right, next. After 10 weeks, Carmen will save 150. So if I take 10 as N and plug that in right here, negative 15 times 10 shows me she'll be saving 150. Check. If I look at Mia, her rate of change, and take that and plug in 10 right there, I get 120. So that one works as well. Mia will save 212 weeks, means taking negative 12 and plugging in N is 12. So plugging in N is 12 right here gives me $144 she's saving. That is not true. All right, bottom ones. I'm going to call this triangle P, Q, R. This is triangle S, T, U. Going in that same pattern. P, Q, R, S, T, U. Don't want to mix up that order looking at this. All right, this says, according to this information, which answers down there are true, which are correct. So this says PQ is equal to ST. PQ equal to this length ST. PR equal to length SU. PR equal to length SU. QR equal to length TU. And I can see right there, side, 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 already congruent triangles. So that one already is true. This one says angle P is equal to angle S. So I'm going to draw one little line like that. Angle Q is equal to angle T. I'm going to do two marks like that. Angle R is equal to congruent to angle U. I'm going to draw three marks right there. So if I did not have these three sides there, angle, angle, angle would not be congruent. But because I have three sides, congruent. And again, all the congruent formulas or postulates, side, angle, side, angle, side, angle, side, 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 and then of course angle, angle, side. All right, this says there exists a rotation of PQR to make this STU. There's no way I could rotate this using paper there's no way I could get this to this exact spot. That is not true. It says there exists a translation. A translation is just a slide, moving something over and up, or over and to the right, or over to the left. If I took this and moved it up and shifted it to the right a little bit, it will give me the same triangle. So that is good. Angle T is equal to angle U. Angle T? Nope, these are not equal. I could tell because these marks right here, these three, show these are equal, but these are not. So I could tell looking at congruent triangles that these are equal, but these are not equal. Three lines, two lines, that is not true. Triangle PQR can be reflected across a certain line. So there is no line I could draw to reflect this over to get that. PQ equal to QR. PQ equal to QR. I could tell again that's not true by these little lines showing because of congruent triangles. Equal, equal. But nope, these are not equal. All right, the 10th word is coming. That is the word 6. That's the 10th word. All right, 30. Almost done. All right, 30, another rate problem. So this one says, Mr. Brown's lawn, Mr. Garcia's lawn. After it's mowed, Mr. Brown's lawn has a height of 3.5 centimeters. That is what its height is at the beginning. If you were to make a data table at 0, 3.5. It has a rate of 0.5 centimeters per day. That is if it's rate of change or it's D. Again, if you were making a table, after 0 days, 3.5, 1 day, 4 inches, 2 days, 4.5 inches, 3 days, 5 inches. So these are like our X numbers. These are like the Y numbers that get spit out after I do the change to them. So this one has a rate of change of 0.5. So I'm going to say Mr. Brown, I'm going to say his equation is 0.5x. Alright, I need to now find the rate of change for Mr. Garcia. So again, this is Mr. Brown. Mr. Garcia, to find its rate of change, again, this is X. This is Y. Find the change in Y. Divide it by the change in X. This is changing by 3. This, if I see the change, if I take 5.2 minus 4.3, I get 0.9. If I divide the change in Y over the change in X, also could get that by subtracting the Y coordinates, remember? But that would give me 0.9 divided by 3, which on my calculator, that gives me 0.3. So Mr. Garcia's rate of change is going to be used as 0.3x. And I'm going to use these two rates of change to answer these questions. After 11 days, Brown's lawn is 1.7 centimeters taller. Let's see. 11 days, that means plug in X is 11 into Mr. Brown's formula. So 0.5 into times 11 gives me 5.5. If I plug in 11 into Mr. Garcia's equation, that gives me 3.3. And again, I'm going to have to rethink this one here, so I'm going to pause this. Okay, so for this problem, you're going to use the more precise formulas. So I'm going to go back to Mr. Brown here. Mr. Brown, he, at the 0 day, had 3.5 and at a rate of change of 0.5. So his function for Mr. Brown is 0.5x plus the term at the 0, the 0 term, 3. That's Mr. Brown's equation right there. Mr. Garcia's a little trickier. I need to find the 0 term. So if I'm going up and dividing this, I'm going up by 0.3 each time. So 0.9 divided by 3 gives me a change of 0.3, which means that's 0.3 over 1. That means every time I go over a day, I go up 0.3. So the second day, I would have 4.6 inches. The third day, 4.9 inches. The fourth day, when I add 0.3, 5.2. So again, if I go 0.3 adding this way, going backwards a day to 0 gives me 4.3 minus 0.3. That is 4.0, super tricky. So Mr. Garcia's equation is f of x equals 0.3x, its rate of change. Again, changing the change of y over to the change of x. And the 0 term plus 4. That is the equation I'm going to use. So when I'm doing this first problem right here, I'm going to plug those numbers into both of those actual equations right there. So for this one, for Mr. Brown, I'm going to plug in 0.5 times 11 and add that to 3.5. For Mr. Garcia, I'm going to plug in 0.11 or 11 into this 0.3 equation right here, this function, 0.3 times 11 plus 4. Let's see what I get. So 0.5 times 11 equals 5.5 plus 3.5 gives me 9. So after 11 days, his lawn is 9 centimeters tall. After 11 days, Mr. Garcia, 0.3 times 11 is 3.3 plus 4 gives me 7.3. If I take Mr. Brown's height minus Mr. Garcia's, that gives me 1.7. So yes, Mr. Brown's is 9. Mr. Garcia's is 7.3. Yes, that is 1.7 centimeters. That is true. To get full credit on this, you will have to show me this work. Alright, Mr. Brown's lawn grows more per day than Mr. Garcia's lawn. Yep, Mr. Brown has a faster rate of growth than Mr. Garcia here. So that is true. After 5 days, Mr. Brown's lawn and Mr. Garcia's are the same height. There's no way I'm going to plug in 5 into both of these and get the same height. So that is false. Just after the lawns are mowed, Mr. lawn is taller than Mr. Garcia's lawn. Just after they were mowed, that is the zero term. So Mr. Brown, the zero term was 3.5 centimeters tall. Mr. Garcia, the zero term, his was 4 centimeters. So Mr. Brown's taller than Mr. Garcia? Nope, that is false. Alright, down here. This says a residual is large and negative. That would be a graph looking like this, where I have my line of best fit and my point is way down here. Super large negative residual. That means that answer is C. The actual data point is well below the line, the prediction, the predicted line. Maybe an outlier. Maybe all the points were around it and then you had this one way out by itself, an outlier. So that would be C. A residual is equal to 0. That means you have a graph like this and every single point is on that line of best fit. That means you have 0 residuals. So that would be B. The regression line intersects the actual data point. Every point on that line is on that line of best fit. That would have a correlation coefficient of 1.0. Alright, all the residuals are positive. That means something like this. You have your line of best fit. All the residuals are positive up here. Every residual is positive. That means the line of best fit is too low. The correlation coefficient is equal to 0. That means all the data points fall on that line of perfect correlation. So this one actually is the line with every single line or every single point on that line, where this one right here, maybe I had some points with a little residual, but this one point has a residual is equal to 0. So that one point intersects that line of best fit. That's how that one looks. And then for the last one, a pattern of increasing residuals looks like this, with my line of best fit like this, which means my residuals are constantly getting higher and higher. That means my line is not a very good line. That means it better fit here at the beginning, but here at the end did not fit so well. So that one would be E on that one right there. Alright, and then this middle one here is D. Alright, almost done. 32. This one is the tightest fit of all of these. This one is the closest one to 1 or -1. Remember the scale, -1, 0 in the middle, 1. I'm looking for something close to the end of that scale here, so that one would be C. For this one, it looks like it's going up. This one is negative, so would not match. This is really, really low, not this super low, too scattered. So I'm going to go with D on that one. Alright, this one going negative. So the only negative choice left, and of course not quite as good as that, would be A for this one. This one is the most scattered, so that one will get the lowest correlation number. Remember, the lower the correlation number, closer to 0, the more scattered the points. That would be B. Alright, next problem. If I have two triangles, let's look at this. Two triangles for this one. It says all three corresponding sides of the two triangles are equal. That means all three sides are equal. Does that show enough to show they're congruent? Yes, side, side, side. That would be a yes right there. At least two pairs of corresponding angles are congruent. That means this is equal, this is equal, this is equal, this is equal. But I could extend this out and still have the same angle. So that one would, or not have the same side. Two angles are not alone enough to know if it's congruent. I would need another equal side in there to make that angle side. Since they don't give it to me, that is a no. This one, a rigid motion carries one of the triangles onto the other. So if I took my two triangles, and if I moved it and slid it, and they carried and touched each other, if I move this one over the top of that one and they fit, that proves they are congruent. And then this one, at least one right angle in each triangle. That just shows you just one angle that they share. That wouldn't be not enough to give you congruency. If I had a hypotenuse and an angle, a right angle, then that would be good. But that one is a no. Alright, 34. Alright, the last word is hill. The last word is hill. So all the words are the, blue, car, bad, went, Joe, over, high, the, 6, hill. So the, blue, car, bad, went, Joe, over, high, the, 6, hill. Those 11 words make up that phrase. So the first word is the, second word blue, third word car, fourth word bad, fifth word went, sixth word Joe, seventh word over, eighth word high, ninth word the, 10th word 6, 11th word hill. Alright, let's finish this last one here. I need to get 2 points that make a parallelogram. So what I'm going to do, I'm going to follow this pattern to get my other 2 points. So my first pattern, I'm going to go to get to here, I'm going down 4 and right 2. So I'm going to go to this point and go down 4, right 2, following that same pattern I did right here. Gives me my next point that would make a parallelogram. You can see a parallelogram right there. So that coordinate I'm going to call A is 1, 2, 3, 4, 5, 6, 7. That is the coordinate 7 for X, -2 for Y. My next one, instead of going down and to the right, I'm going to take this point and go left 2, up 4, left 2, up 4, and take this one and follow that same pattern. Left 2, up 4 will give me my next point that gives me another parallelogram. So right 2, up 4 will be right here. I'll call that B. That is the point 1, 2, 3. 1, 2, 3, 4, 5, 6. That's the point 3, 6. So that is A and B. Alright, I need to prove that this quadrilateral is a parallelogram. So I'm not going to prove these rectangle parts right here. You can see that rectangle. I'm going to do the parallelogram. So I'm going to draw that so we could see. Probably should have used a straight edge, but that's okay. I'm going to prove that these two sides are parallel, and then these two sides are parallel. If I could do that, that proves it's a parallelogram. So for this, I'm going to do the slope between K, T, Z, and A. K is the point -3, 3. T is the point -1, -1. Z is the point 5, 2. A is the point 7, -2. So my first slope is KT or TK between these two. So I'm going to take my Y's over the top, my X's on the bottom. Remember, slope is always the Y subtracted up high over the X's on the bottom. This is going to give me, for KT, it's going to give me 3 minus a -1. 3 taking away a -1 is 3 plus 1 over -3 minus -1. That's -3 minus -1. -3 plus 1. That gives me 4 over -2. So the slope of KT, we'll say that slope is equal to -2. So this is -2 right here. All right, find the slope between K and Z. So K and Z, might want to write those points right next to each other so you can see them a little bit more clear. 3 over 3 minus 2 over -3 minus 5 gives me 3 minus 2. Sorry about that. Get this out here. 3 minus 2 over -3 minus 5 gives me 1 over -8. So that is my slope of this section right here. Every time I go over 8, I go down 1. All right, next is ZA. So I'm going to write those coordinates next to each other to help myself out. Subtract the Y's up high. Subtract the same direction. You don't want to go one direction with the Y's and the other with the X's. Don't want to do that. Stay consistent with your direction. Gives me 2 minus a -2. I'll show the double sign right there. Over 5 minus 7. Gives me 2 plus 2 over -2, which is 4 over -2, which is -2. So this is the slope of ZA, -2. This was the slope of KZ. Next, I need to find the slope of my last section, which is TA. So I'm going to take my points and write them next to each other again so I don't make a mistake. That's going to give me Y's on top, -1 plus 2 over -1 minus 7 gives me 1 over -8. So I could see these two parallel, same slopes. These two parallel. When you have a shape like that with two corresponding sides of parallel lines, that is a parallelogram. That is my proof showing that work right there and putting those numbers in there. All right, last. Box and whisker. It's already in order for you. I'm going to find the middle number counting in from the outside. So 10, 40, or I'm going to cross them off. So there's that. Next one. Third one. Fourth one. Fifth one. Sixth one. Seventh. Eighth. So I can see these two middle numbers I'm going to use to find my median of the whole set. So that is 28 plus 28 divided by 2, which obviously is going to give me 28. But 28 plus 28 is 56. Divided by 2 is 28. But now, that is my median. To find the median of the top half and bottom half, I'm still going to use all those numbers. So those of you who I told different, make sure you fix that. I'm going to use all those numbers to find the top and the bottom median. So the median of this bottom half, if I look at it, is 20. The median of this top half of numbers, if I go from the outside, is 36. I can tell I have 4 on this side, 4 on this side, 4, 4. These are the max and the min, so I could already fill in my answers. The minimum, the low number 10. The maximum, 40. The median of the whole set, 28. The first quartile, 20. The third quartile, 36. If I make my box and whisker plot, I'm going to start at 10 and go by 5s. Do not go by 10s or anything greater. You might be able to fit it in, maybe going up by 2s. Alright, so here we go. My bottom of my box and whisker plot at 10. My high number at 40. My lower quartile, my first quartile, the edge of the box, 20. My middle quartile, 28, just to the left of that 30 line. My top quartile, 36, just to the right, be precise, of that 35 line. Fill in my box. Fill in my whiskers. This shows me that it looks like my median here is shoved off a little bit to the right. Looks like my tail is longer to the left. This is left skewed. I guarantee if you found the mean of these numbers, the average, my median is going to be to the right of my mean. That is all my data shoved up here to the right, with my other data tailing off to the left. There's my long tail. That is left skewed. Alright, good luck. What I want you to do for the word, the message, I'm going to have you write that out and cross off every second number or every even number. You're going to cross off the second word. You're going to cross off the fourth word. You're going to cross off the sixth word. You're going to cross off the eighth word and cross off the 10th word. You should have a 1, 2, 3, 4, 5, a 6-word phrase to give me, to prove to me that you watched this video. All right, good luck.